This is originally was made by Garrett for Caterpillar. This is a high pressure off a Cat C15. I believe it's an MXS engine. But kind of a cool turbo, one, because most people with a C15 go to a single setup, like a single S475, S480 Borg-Warner. But this gentleman has four, I believe it's Kenworth's W900s with the C15. And so what's kind of cool about this turbo, one, yes, I said it already, Garrett originally produced it for Caterpillar. Fun fact, Caterpillar was Garrett's first customer. I believe they have account number 1 with Garrett. But what's cool about this, and you don't see it much, is this has a titanium compressor wheel. And that's why this compressor cover is cast iron, because for burst containment, if something goes awry and you use a titanium compressor wheel, it's just gonna mill its way out, right out the compressor cover. So you have to use cast iron when you use a titanium compressor wheel. But this was fun because, again, most of the time people use a single setup just for reliability, albeit I think actually the high pressure, low pressure in this application, not all, is actually a pretty good one, pretty reliable. But secondarily, you know, I started on these when I started out when I was back in 2007. So these were really prevalent back in the day. Then people started converting. So this guy has 4 different W900s, all still running high pressure, low pressures. Simple journal bearing setup. I think it's a GT45, and then it's accompanied with the low pressure, which is a GT55. Build super easy. You need to know your tolerances on these. But I also, what was fun about this job, and I think what I really probably enjoyed the most by the end of it, painting it. Shout out to Seymour. Never use your guys' product. Pretty good. Pretty good. This is new equipment yellow by Seymour, part of their bid rid line. It lays down super easy. It cures quickly. So this is, I sandblasted everything. This is a couple coats. I think it does a pretty good job matching Caterpillar yellow. I think they call it the new yellow. I'm not a Caterpillar expert, but I'm pretty sure it's new cat yellow. Really good job, super durable. Like, I'm pretty sure this is a heavy solid enamel. Try it out. It's pretty good for yellow, cat yellow stuff. But this is really, I mean, this is cool. This is the bee's knees. Growing up, building turbos, always used dried graphite spray from CRC, which is it's a great thing for, especially if you're ever rebuilding a turbo, if you're trying it yourself, or if you're a shop and you're watching this. A lot of the VGT turbos out there, Garrett, Borg-Warners, the whole sets, even IHIs, if you're rebuilding it, dried graphite spray, it flashes super quick, so it dries. And it's a lot of lubricity. It handles high temperatures super well. So good for the VGT mechanisms inside the turbine housing. But I've been looking for a turbine housing spray that matches the cast iron pretty well. Wow, this thing's so heavy. Which I think this does a pretty excellent job at actually like mimicking pretty close to what like natural cast iron is, you know, fresh out of a foundry or a casting. Lays down easy, flashes, dries super quick, seems to be pretty durable, and the best part about it, I mean, 1200 degrees. Like that's pretty good for paint. You go try to find paint that handles 1200 degrees. Most is like 500, 550. So 1200 degrees. I'm going to ask the customer once he picks up the turbos and puts them on to see, you know, what the actual durability in life is. On a high pressure setup, it's going to get really hot anyways, just due to the nature of how the design is. But shout out to Seymour. I really like your product. So thank you for making a good one. This was a fun job. It's pretty cool to get to work on these older Garrett turbos, do a lot of VGT and the newer stuff for the emissions vehicles, but see someone still running one of these is pretty cool. So I want to talk to you about some of the equipment that was used during this process. So any turbo that comes in, first thing we do is tear it down. Once we have it torn down, which tear down for every turbo is different, just because some fight you every bit of the way. But we tear down, and then the more critical components go into the ultrasonic cleaners. Just a light degreaser. It helps get a lot of the gunk away to give me a fresh surface or a good picture of what's going on. So say the bearing housings, the turbine wheel and shaft. I like to look at the back plates, the seal bore area to make sure that it's not dulled or scored. And then I'll do some quick blasting on the housing, especially a housing that's wastegated, because sometimes soot and a bunch of other stuff will build up and block things that you need to see, which would be like checking for cracks and other wear, that erosion within the volutes, to make sure that the housing is usable. So I'll do that. We ultrasonic the critical components, and then that gives me a good foundation of how to quote. And then once I have my parts list, then I can kind of gauge, is it better to replace with an OE unit, or is it more cost effective and give you a good a better product, a new product at that point, or is it more cost effective? For this customer and what we had to replace, we replaced the actuator. His original one was fine, but with close to, I think he said it was 900,000 miles. I don't remember, I could be misquoting, but it had been on the vehicle for on the truck for a long time. We've replaced the actuator, replaced jam nut, the circlip, had to replace V-band clamp. The threads were all stripped and stretched, and then full bearing seals. So we did the quote, customer approved, at a cost savings significant over even the OE replacements or Caterpillar. And so once approved, then things start going. So all the cast iron gets dry blasted. I like to use a product called 10 EXM, which is 10X engineered materials. For those who do a lot of blasting, check them out. They're really safe. You don't want your team sucking in all that dust. It's nasty stuff. I'm sure we all grew up with some of the older stuff and didn't wear proper PPE. We just did safety squints and plugged your nose, and at the end of the night, then you had some weird looking snot coming out. But we blast everything. I really focus on the bore areas. That helps make sure that we have a good seal when the units go back together. We also will knock all the rust. That's really just getting rid of all the years of corrosion. Since this every housing on this turbo is cast iron, as well as the low pressure, the bidder unit, all cast iron. Every housing, even the back plate. It was a lot of work. Once we dry blast, then it's okay. We got all that off. We need to clean it, and so it goes ultrasonic cleaned again. And that makes sure that nothing's in the bore, nothing's in any of the oil passages. It gets everything, especially in the bearing housing. I want everything out. That has to be the cleanest thing as possible, because some of the number one leading causes of failures is 1, lack of lubrication, or 2, contaminated oil. And we're not going to start a rebuild off giving you a turbo that's contaminated already. So really focus on cleanliness. That's why we do assembly in a clean room. It's away from the dust, it's away from everything else, so that we can have, we use different tools so that there's no grease, no contamination, nothing. So that's really important. So We'll ultrasonic clean everything, get all the dust, and then the shaft gets chalked up to be polished, provided there's no storing or anything. We use V-blocks and dial indicators to check for shaft straightness. That's really important. There's an allowable tolerance of bend within a shaft, and you're talking 10,000, so it's not much, but so we use precision V-blocks. We'll dial indicate it, make sure that the shaft is straight, because you cannot, if your shaft's bent, it will end up pressing the oil away from the bearings, ending up making contact. It also, weird harmonics, it'll grenade a turbo pretty quickly if you have a bent shaft. So we polish, check that. We go back into we'll take all the parts. By then we've gotten the parts, or if we had the parts on hand, and then we start assembly. And with this unit, we didn't have to replace any of the rotor group, so we can, it is a boreless wheel, but we can indicate based on the factory torque specs, which is a torque plus angle of degrees when you torque it all together. So no need to rebalance. We're not replacing any of the rotor group. And so yeah, we go through and go one by one, part by part, double checking that your piston ring gap in the back plate or the seal plate bore, making sure that it's within spec. We're checking same thing on the turbine side within the bearing housing sealing bore. We'll mic all the bearings, thrust bearing, thrust collar, check to make sure. That's one of the biggest measurements that you need to make sure that is minimal, is axial tolerance, which is in and out play. So in and out play with the compressor wheel, that's axial, and then radial is the up and down movement. We do our assembly, we torque everything with really quality torque wrenches, and then it gets chalked up in a vise, the rotating assembly. That's when we check for axial and radial movement. Goes back together. We do some paint. On this, we did not, because it's cast iron, I don't aqua blast just to prevent flash rust. But with aluminum housings, aluminum compressor covers, aluminum back plates, we'll aqua blast that. That does such a good job. Shout out to Vitson. Vitson makes an incredible heavy duty. I mean, they're worth their weight in money in what you spend. We don't do it on these, but 99% of all turbos are not this all cast iron. So, but yeah, we assemble, check radial and axial torque specs. We'll install the wastegate actuator. This one is a threaded fitting. We will put a dial indicator on the wastegate puck, make sure that it's opening to spec. I think this one's like 29.5 psi to 31.5 psi at 39 thousandths of lift. So we put pressure to it, make sure the wastegate's tracking at the right pressure is opening to the 39 thousandths of lift. We do our paint with Seymour. Hey Seymour. And it's a wrap. It's a turbo done.